Hello, welcome to our series where we solve the questions in the WASSCE 2019 May-June Elective Maths Paper 1. We're going to solve all the questions in the paper and we're going to try to keep the videos short, so we do about 10 questions per video. And this is the first one. The first question is solve 8 to the power x minus 2 equals 4 to the power 3x. The trick we're going to use here is we want to write both sides in the same base. So luckily for us, we know that 2 to the power 3 is equal to 8, and then 2 to the power 2 is equal to 4. So we substitute these values into the equation and we get 2 to the power 3, that's 8. Now that's to the power x minus 2, and that's equal to 4, which is 2 to the power 2, 2 squared, to the power 3x. And by the laws of indices, the indices on this side should multiply. So this should simplify to 2 to the power 3 times x minus 2. And then this on the right hand side, we have 2 to the power 2 times 3x. Because the bases are the same, we can equate the exponents, and then we get 3 times x minus 2 equals 2 times 3x. Simplifying gives us 3x minus 6 equals 6x. Now grouping like terms, we get minus 6 equals 6 minus 3x, which is 3x. And that gives us x equals minus 2. So our answer is B. The next problem says evaluate tan 75 degrees, leaving the answer in surd form or radicals. What we do here is to write 75 degrees in terms of angles whose trigonometric ratios we know. So we know that 75 degrees we can break it down into 30 degrees plus 45 degrees. And we like 30 and 45 because we know the trig ratios for 30 and 45. Using the fact that the tangent of a sum, that's the tan A plus B, is equal to tan A plus tan B all over 1 minus tan A tan B. Using this fact, we know that to calculate tan 75 degrees, we're going to need the tangent of 30 degrees and the tangent of 75 degrees. So we can note those facts somewhere. We know that tan 30 degrees is equal to 1 over root 3. This is the same as root 3 over 3. Well, you can verify that by rationalizing the denominator. We also know that the tangent of 45 degrees is just 1. Now these are trig ratios that you should have memorized by now. So if you don't know them, you can rederive them or just go and refer to your textbook and remember them. But to solve a problem like this, you need to remember these ratios. So knowing now tan 30 and tan 45, we just substitute them into this formula. So if we say that A, we can say let A be 30 degrees. So let A be 30 degrees, and then B 45 degrees. So you just substitute. So tan 75, which is now tan A plus B. I didn't have to put the 75 in brackets, but it doesn't matter. So tan A will be tan 30, which we said is 1 over root 3. Tan B is tan 45, which we said is 1 over 1 minus tan A, which is 1 over root 3, and tan B, which is 1. So 1 over root 3 times 1 is the same as 1 over root 3. So we have 1 over root 3 plus 1 over 1 minus 1 over root 3. Another way to think of it is this is the same as 1 plus 1 over root 3 over 1 minus 1 over root 3. So we would like to rationalize or otherwise do something to make the answer look like one of the options we have. And one thing we can do is to multiply both the denominator and the numerator by the same number to get rid of the fraction. So we can multiply both by the square root of 3. And when we do that, what do we get? By multiplying the denominator by square root of 3, this first one, change pen, the first one becomes this number times square root of 3 becomes 1. And then this 1 times square root of 3 becomes square root of 3. And then for the denominator, we have 1 times square root of 3, which is square root of 3, and then 1 over square root of 3 times square root of 3 is that. So we get this. And then we now have to simplify or further rationalize. And we can do that by just multiplying through by the conjugate. So multiplying by the conjugate, which is, let me rewrite this. So we have 1 plus, let me create even more space. We have 1 plus square root of 3 over square root of 3 minus 1. We want to now multiply both the denominator and the numerator by the conjugate. So we have square root of 3 plus 1 over square root of 3 plus 1. And when we simplify, what do we get? Well, this is now a square. We have 1 plus square root of 3, and here we have square root of 3 plus 1. So that was the square of this number, 1 plus square root of 3. We have 1 squared, which is 1, plus 2 times 1 times square root of 3. That's 2 times the square root of 3, plus the square root of 3 squared, which is 3. And then for the bottom, we have a difference of 2 squares. Basically, this is the factorization of a difference of 2 squares. So we know when we multiply, we should be getting that. And the result we should get should be this number squared, 3 squared, which is 3, minus 1 squared, which is 1. So we have this number over 3 minus 1. Simplifying the top, we get 1 plus 3, which is 4, plus 2 root 3. And then for the bottom, the denominator, we get 3 minus 1, which is 2. So 4 plus 2 root 3 over 2. What does that give us? We have 4 over 2, which is 2. And then we have 2 root 3 over 2, which is root 3. So that's our result, 2 plus the square root of 3. And looking at the options, that's the same as this one. In a problem like this, you may want to check with your calculator as well, just to verify that you're on the right track. All right, so we go to the next question. Solve p over 2 plus k over 3 equals 5 and 2p minus k equals 6 simultaneously. All right, so we have two equations in two unknowns. The unknowns are p and k, and we have to solve them simultaneously. Looking at this first equation, we have a bunch of fractions we may want to get rid of. So how do we get rid of the fractions? We can multiply through by the LCM of the fractions. So the LCM of 2 and 3. Now the LCM of 2 and 3 is 6. So we can multiply through this by 6 and see what we get. 6 times p over 2 now becomes 3p. And then we have 6 times k over 3. That becomes 2k. And then 6 times 5, that's 30. And then this equation, we just use it unchanged. So we have 2p minus k equals 6. So these are the two equations. We can number them. call this equation 1, call this equation 2. What do we want to do now? One thing we can do is to eliminate one of the variables. So in this case, it looks like it'll be a little easy to eliminate k. We do that by first multiplying through equation 2. We multiply equation 2 by 2, and then what do we get? So let me write down what we get. Equation 2 times 2. What does that give us? That gives us 4p minus 2k equals 12. The reason we multiplied equation 2 by 2 is so that we get 2k here, and then we can eliminate the k by adding the new equation 3 to equation 1. So now if you add equation 1 to equation 3, what do you get? You get 3p plus 4p, which is 7p, and then plus 2k minus 2k, that eliminates the k, and then you have 30 plus 12, which is 42. So if 7p equals 42, that implies that p equals 6. So that's the first step. Having found p to be 6, we now have to find k. We can substitute into any of the preceding equations, but equation 2 looks very attractive because we have k standing alone. So substituting into equation 2, what do we have? We have 2p, which is 2 times 6, minus k equals 6. That means 12 minus k equals 6. That means k equals 6. So we have p equals 6 and k equals 6, and the option that has that is option A. So we go to the next question, question 4. It says we should rationalize 1 over the square root of 2 plus 1. Again, to rationalize, we just multiply both the numerator and the denominator by the same number, and that special number that we multiply by is the conjugate of the denominator. So here the conjugate is square root of 2 minus 1, and we multiply the numerator by the same thing. Now doing that, we have this numerator times 1, which is the same as the square root of 2 minus 1, and then we have the denominator, again a difference of 2 squares, so the result is going to be the square of 2, so the square of the square root of 2, which is 2, minus the square of 1, which is 1. Now 2 minus 1 is equal to 1. Any number divided by 1 is the same, doesn't change. So we have square root of 2 minus 1 as the final result, and that is C. So we go to the next problem. That's question 5. Here we have if n choose 2, or if n combination 2 equals 15, find the value of n. Now, one way to do this is to expand this term that says n combination 2 or n choose 2. And n choose 2, what does it mean? It's the number of ways of choosing 2 items from a set of n items. And the formula, if you recall the formula, then you can use it. The formula for n choose 2 is n factorial over n minus 2 factorial times 2 factorial. That's the formula. So if you remember this formula, then one thing you can do is to simplify the formula and then equate it to 15 and then solve for n. That's one thing we can do. So let's do that first. It's not the only way to solve this problem. Another way to solve this problem is to use Pascal's triangle, and we'll come to that, but let's first use this formula to see what we get. So n factorial over n minus 2 factorial times 2 factorial. How do we simplify that? The idea is that n factorial can be written as n times n minus 1 factorial. Any factorial can be written this way. And once you write it this way, you have to know that n minus 1 factorial is also equal to n minus 1 times n minus 2 factorial. So this is the trick, because when you write n factorial this way, then you can come back here to the top and you have n times n minus 1 times n minus 2 factorial all over n minus 2 factorial times 2 factorial. And now you have to simplify this new expression. But you can see right here that you can cancel out, because you have n minus 2 factorial in the numerator and n minus 2 factorial in the denominator. So you can cancel them out, and then you're left with n times n minus 1 over 2 factorial. So let's bring that down. If we bring this expression, this whole expression, if we bring it down, what do we get? We get n times n minus 1 over 2 factorial. Now that is equal to this n combination 2, or n choose 2, and we've been told that that's equal to 15, so we write that here. It's equal to 15. Now 2 factorial is equal to 2, so what this simplifies to is that n times n minus 1 equals 15 times 2, which is 30. Now expanding this left hand side, we get n squared minus n equals 30. Now we have a quadratic equation, and what do? We can bring the 30 over, oops, mistake, by subtracting 30 from both sides. We get this, and then we can factorize by first writing n minus 6, n plus 5 equals 0. What does this mean? This means that n equals 6 or minus 5. Now we know that n has to be positive, so the answer becomes n equals 6. This is the method of writing out the formula for n choose 2 or n combination 2, and then simplifying and then seeing the result. But like I said, we can also use Pascal's triangle. When you see an expression like this, you're basically, every expression of this sort, n choose something, can be derived from Pascal's triangle. And what does Pascal's triangle look like? Well, we always start with 1 and 1. So 1, 1, that's the first line, if you will. The second line, we're gonna have 2 in the middle. We always have 1 and 1 on the sides. That's the second line. Now, okay, let's do the third line. The third line is gonna be that 1, 3, 3. I mean, we get a 3 by adding 1 and 2. 1 plus 2 is 3, 2 plus 1 is 3, and then we end with 1. Now we can get the next row, and then the next. The hope is that we're going to get a row in which we're going to have 15 being in the, if you like, the 2 position. Now when you have a row like this, this row, what this represents, it's something combination 0, something combination 1, something combination 2, and something combination 3. I say something, to find that something, you can just read the first number or the row you're on. So this is row 1, row 2, row 3. This means 3 combination 0 is 1, 3 combination 1 is 3, 3 combination 2 is 3, and 3 combination 3 is 1. So that's essentially what we're looking for. We are looking for a row in which something combination 2 is equal to 15. Now, the danger with this method is that if we are not lucky, we have to write down many lines before we find what we're looking for. But we are praying that that's not the case. So the next here is 1, 5, 10, 10, 5, 1. This is row 5. Let's see what row 6 gives us. Okay, we have 15 here. Now, having found 15, we are hoping that it satisfies this equation. Now let's see. We know that this is row 6, right? 1, 2, 3, 4, 5, 6. This is row 6, and this is 6 combination 0, 6 combination 1, and 6 combination 2. So 6 combination 2 is 15 according to Pascal's triangle. And so we found our answer. Yes, just by the fact that this is row 6, this is row 6, 6th row. Because this is our 6th row and we have 6 combination 0 being 1, 6 combination 1 being 6, and 6 combination 2 being 15, we know that the answer has to be n equals 6. So that's how to use Pascal's triangle to solve a problem like this. You are not always going to have it this easy, but I suspect that on the WASSCE they're always going to make it so that you can use Pascal's triangle, so you don't have to write too many rows to find the answer. But you can also use this method where you use the formula and then you expand and then you solve some equation and then you get the answer. All right, the next question is question 6. It says an operation star is defined on the set t equals -1 through 5. That's the integers. And this is the definition. X star y is equal to something. Now we are looking for which of the following operations will give an image in t. So the first one is 2 star 5. What do we have for 2 star 5? 2 star 5 is equal to 2 plus 5 minus 2 times 5. Now 2 plus 5 is what? 7. And then 2 times 5 is 10. So we get -3. Now is -3 in t or not in t? It is not in t. T goes from -1 to 5. So -3 is outside the range. Now the next one is 3 star 2. What do we have? We have 3 plus 2 minus 3 times 2. And that gives us what? We have 3 plus 2, which is 5. 3 times 2, that's 6. So we have 5 minus 6, which is -1. And -1 is in t. Let's look at the next one, 3 star 4. We have 3 plus 4 minus 3 times 4. What is that equal to? We have 7 minus 12, which is -5. Is -5 in the range? No, it is not in t. So of all the options we have, the only one that's in the set is this one, I only. So that's our option. That's the answer. All right, the next question is, given that g is such that x goes to 3x and f is such that x goes to cosine of x, find the value of g of f of 20. What this means, what this expression means, is that first you apply f and then you apply g to the result. So what do we get by applying f? F of 20 becomes the cosine of 20 degrees. And then when we get this, we have to apply g to it. And what does g do? G says whatever you get, multiply it by 3. So this is basically what we're looking for. And we can use our calculator to solve this. If your calculator is able to take in an expression like 3 times the cosine of 20 degrees, then you just punch it in and get the result. The result, corrected to decimal places, is going to be C. Now, if your calculator doesn't let you do this, then you know what to do. You first calculate the cosine of 20 degrees, and then you multiply the answer by 3. All right, the next problem says a linear transformation is defined by t such that xy goes to minus x plus y for one coordinate, and for the second coordinate minus 4y. So find the image of q prime. Find the image q prime of q minus 3, 2. The image of this, we first have to see what minus 3 is going to become, and then we'll see what 2 is going to become. Now minus 3 is going to be transformed into minus x plus y. Now what is minus x plus y? Minus x plus y is minus 3, and then the y is 2. And what does that give us? It gives us 3 plus 2, which is 5. And then we have minus 4y. What does minus 4y give us? Minus 4y gives us minus 2. Oh, sorry. It gives us minus 4 times 2. And minus 4 times 2 is minus 8. So the coordinates of q prime are 5 minus 8. And that's what this is giving us, C. All right, so let's go to number 9. It says if G is such that R goes to 5 minus 2R, where R is a real number, find the image of minus 3. Here we just proceed by substitution. The image of minus 3 is what we are going to get when we put minus 3 into this expression. So we have 5 minus 2R, but our R is now minus 3. So we get 5 minus 2 times minus 3 is now plus 6, which is equal to 11. So that's our result. Now we go to the last problem in this series. That is problem 10. It's a little long, so okay. It says consider the following statements. P. Statement P is that birds fly. Q. The sky is blue. R. The grass is green. What is the symbolic representation of if the grass is green and the sky is not blue, then the birds do not fly? So we have an if-then statement. An if-then statement basically means that you have an implication. If blah blah blah, then blah blah blah. So immediately we know we have an implication. The left side of the implication is what is here. If the grass is green and the sky is not blue, then birds do not fly. So the then side is on the right side. So we can tackle it in two parts. It says then the birds do not fly. Now our statement P says that birds fly. Now birds do not fly is the opposite or the negation of the statement. So we know that on the right side we have the negation of P. We have the negation of our statement P on the right side. Now on the left side we have the grass is green and the sky is not blue. So we have a compound statement, or the conjunction of two statements. And the first part of the statement is the grass is green. We've been told that the grass is green is the statement R. So we know that we're going to have R and something. The end is with this part. The sky is not blue. Now, the sky is not blue is a negation of the statement the sky is blue. So we have R and the negation of Q. So this is it. We have R and not Q implies not P. And which one is R, or which one is the same as what we have here? It looks like A is our answer. A is precisely what we have at the top. So this is the end of the first section. We've solved the first 10 problems in the list, and in the next video we're going to look at the remaining questions. See you. Bye.